Hello everyone, welcome to my channel. So we are solving blind 75 list, and this is so far we have covered all these video solutions are done, and all these topics means bits and bits out of all these topics are being done, and all the videos have been uploaded to my this playlist which is there, and you can follow this particular playlist while solving those questions. So the whole lot of 48 videos are already uploaded, and the remaining ones, because these are total 75 questions, mm, two questions are there which are like additional ones which are there in that blind 75 list. But yeah, 48 out of all those have been already uploaded. So now today, which question we are going to do is, for this one, find medium from the data stream. The question link is here, and we will be going ahead reading that question and doing what all is required for that question. So let us just begin with this question. So before we start with this question, what we are going to do is, basically we need to check out, read this question, and then check what are the possible not possible, but what are the exactly constraints of this particular question, and then whatever possible solutions could be there, that all we are required to go ahead and check means any brute force solution, and even after the brute force solution, what optimized solution we could think of, that all. Then implementation part, basically coding that. I'm basically coding in C++, but if you want to code in any other language also, that is all your choice. It doesn't matter that whatever language you choose, the only thing is that you should be well aware of how to code the data structures of that particular, means in that particular language. That is the most important part. And then the time complexity and the space complexity for the same. So now comes the part. Let us first read this question, then I'll explain you that what we can deduce from this question, main terminologies of this question, and then we'll think of what could be a brute force solution, and then the optimized version. And we'll also compare the time complexity, space complexity of all those solutions. So now without any further ado, let's start. So here, the median is the middle value in an ordered integer list. It is the size of the list is, if the size of the list is even, there is no middle value, and the median is the mean of the two middle values. For example, array 2 3 4, here the size of the array is basically odd, that is 3. So the median here is 3, the middle value, right? But for example, array is 2 comma 3, its size is basically even, that is 2 is the size, right? So the median would be 2 plus 3 by 2, that is 2.5. So implement the median finder class. Median finder initializes the median finder object. So this is that median finder. So here this median finder class which is there, median finder constructor which is there. So void add num, int num, adds the integer num from the data stream to the data structure. So basically we are given with the input which will be acting like the data is coming in the form of stream. So this particular uh, function add num which is there, that will be adding the number coming from the data stream, and it will be having a single input num. That is the thing each time when that particular function is being called. Now, double find median returns the median of all elements so far. Answers within 10 to the power minus 5 of the actual answer will be accepted. So basically, here the find median function which is there, we are required to implement this whole class as in to get the find median as our answer. Now the thing is that this median finder, this is just for creating the object of the class, so that's why it is null. Add num will be having the input which is, in this case 1 is there, then again add num which is there, it is having input 2, right? And then when find median is there, we don't require any input, whatever data we have stored so far, so on that only we would be required to return the median. Here the return type is double, right? So we would be required to return a double value, and here the return type is void, so that simply means here it is just adding up all the numbers, adding up in the sense appending or doing something like that. So that is what is being done here. So that is the part here. Now comes the part that uh, how it works. They have explained that fact, so we are not that much concerned about this particular thing. Now comes the part for the constraint. So basically constraints for this particular is that there will be at least one element in the data structure before calling find median, so that the find median function actually works. That is the scenario here. And then this minus 10 raised to power 5 means basically the values which are there, those will be in the range from minus 10 raised to power 5 to 10 raised to power 5, and at most 5 into 10 raised to power 4 calls will be made to add nums and find median. That simply refers to that at most there could be 10 raised to power 4 elements which will be there in the data stream. That's why they will be calling at most this much time. So that is what we deduce from these constraints, and these constraints are pretty much helpful for writing our further test cases. So that's the scenario here. Now follow up says that if all integers number from the stream are in the range 0 to 100, how would you optimize the solution? Means basically, if we don't even think about the fact that minus 10 raised to power 5 to 10 raised to power 5, these are the num range, we just check for the range 0 to 100. Then how you will optimize? Means if you take a smaller set, in that how you will optimize your solution. That is what they want to say in this particular follow-up. That is all. But now let us first start with the brute force solution for the same, like what brute force solution we can think of and so on. Then accordingly we will be going ahead for the same. 1 minute, let me get my so now here let me first explain, then I'll go ahead. So let us first take one example. Okay, so if we take one example, this 1 2 3 4 5, let us take this example 1 2 3 4 5 and 1 2 3 4 5 6. This anyhow, okay, let us first think of the brute force solution for the same, then I'll explain that part. So now here the thing is that data is basically coming in stream, right? So there would be some of the things like till now we got 1 2 3 or something like that. Let me write. So see, like we could be having like this 1 2 3 data was coming in stream, right? So data is coming in stream, so at earlier 1 is there. So here if find median is called, so 1 would be returned as it is, right? Then 2 is called, then 2 and 1 we need to add up and do, and 1.5, this is what median would be returned, right? So anyhow data would be coming in stream, and the function which is there, that is this add num. So what we can do is the brute force solution which we can think of. We can have some storage, any sort of storage is fine, either vector, array or anything like that. Vector, yeah. And because it is coming in stream, we don't even require its ordering. What we require is like whatever numbers are there, we are just required to figure out the median of the same, and the number would be coming in the order they are required to get the median. So anyhow, because they are coming in order, so in that context we can take array is also fine. We just need to figure out the middle element to just figure out for the median. That is the thing. So for so let us just take a vector, right? This I'm telling the brute force solution, and in this vector, whatever vector we will be taking, let us say a, we will be just pushing whatever we get, means whatever num we are getting from this add num function, we will be just pushing that particular number into this. And because this is a global one, not global as in global of everything, but just class global, means inside that class we will be having, or just make it as a private only, private member of that class. That would be much better option rather than going ahead with making it a global. So we'll just make it as a private variable, the private variable that we can do this particular. And because this is a private variable, we and in that class we will be able to access this particular data structure. And what we will be going to do is we'll just add number to this particular, and whenever this find median is there, we'll just check the size of this particular vector. If it is odd, then whatever is n by 2 means n by 2 index, that will be our answer. Else we'll take n minus 1 by 2 plus n by 2 means indices a of this and a of this. That will do, right? And simply we'll add them and do half, and that will be our answer, and we'll just return that answer. This is the brute force solution which we can think of for this particular question. So that is what I was thinking at the start when initially I had when I had solved this particular question, I was thinking something like this and I solved like that. But now comes the part that when we are going to solve it something like this, it will occupy this much space, and yeah, after occupying this much space, then again we will be required to go to that particular place and get our answer, and so on. We can even think of some other sort of solution also for just solving this, because in this particular we will be required to sort it also. Anyhow, when we are taking this vector, we need to sort it so that we can figure out the median. Because see, when we are required to figure out median of any particular array, that should be sorted. That is the thing. And here they have not mentioned that it would be in sorted nature or not, so that's why it is required to be in sorted order. So every time total n elements which are there, they will be required to be sorted. So that is one of the things which will be required in this question. So that will become like n log n solution for this adding num part. That is the thing. Anyhow, figuring out median, that is just a mathematical calculation, and that would be order of 1. So for getting more optimized version of this, okay, let me write this brute force solution or something which I was showing earlier. I'll pause and write and show you. Okay, so this is the brute force solution which I was telling earlier. So basically for this particular, we need array, and in that we'll store that and then sort it. Means every time we will be doing that will be performed in a log n solution, that is for sure. Then when median is that find median function which is there, whenever that particular function is called, then in that particular scenario what we would be required to do is that we will be basically checking the size of the array. If it is even, we'll perform the mean for the two middle elements. Else, in the case of odd, we will be just returning the middle element. So that is all what we will be doing in the brute force solution. But overall time complexity for that add num, that will become n log n, that is for sure. And for this one, anyhow, it is mathematical operation, so it would be order of 1 only. So this is how time complexity would be there. And in this space complexity is also there, that will be order of n, the number of elements which are there. So now comes the part that how we can further optimize it. That is one thing. So now for the optimization part, let us take one more example and observe this, that how we can go ahead and choose things all around. So now the first thing, if the elements which have been accumulated, those are basically, if you don't take it as a stream, if you just take it as that there are some elements there in array, just think about that. About the stream, we'll discuss about that later point. First, let us just check about that if it would have been an array where some elements are there, how you would have solved. So here, if it has odd number, we will be selecting the middle element. If it is even element, right, means even number of elements, then we will be selecting middle two elements, right? And if you observe, what exactly is being required, the largest of the first and smallest of the second. Means if we divide this particular in two parts, in case of in case of even number of elements, we require the largest of the first and smallest of the second. That is where our main thing comes into picture. The main thing is that what we can choose, means what type of data structure we can choose to just eliminate that fact of n-log and time complexity to somewhat more optimized version. So for that fact, we will be taking two heaps, because anyhow when these particular numbers which are there, these are coming in the form of stream, so that heap will be anyhow storing the whatever numbers which are there, those would be stored optimally in those two heaps, and it will be sorting uh, basically in the worst case scenario it can go to order of n, but not in every point it can go to n. Worst case scenario, in that worst case scenario is that when there is just one element, that would be that worst case scenario, but all other scenarios it will be always divided in half. So here we will be basically, whatever elements are there, we will be dividing them into two parts, that is for sure. And after dividing them in two parts, accordingly the time complexity will also grow down, slows down from that basically n log n to something k log k, something like that. And that k we can define as the half of that n, and accordingly our whole time complexity will burn down to something more smaller than what it was earlier. So that's the thing. Now for getting into the that how we are going to implement and so on, let us first observe that how we can do and so on, then I'll go ahead with the implementation part, else you won't be able to get into that how and why we are implementing like this and so on. So now this thing is clear that anyhow if we divide that particular stream into two parts, and anyhow that particular is a basically stream, not a just a given array, right? So for that stream we will be taking two max heaps, that would be the thing, and that will play the role of sorting them. Sorting those two heaps means taking fewer elements and sorting them, so anyhow that will add up rather than being multiplied, so the time complexity anyhow will go down. Now the second step which is there, how to decide to choose from the large sorted heap or both, means basically what we are going to do is mean dividing these two heaps, means what element goes in large, what element goes in smaller heap. Here large and small refers to the basically the heap which gives us the largest element of all which are present in that heap, and small refers to the heap which gives us the smallest element out of all the elements which are present in that heap. So that is what referred by large and small heap, which I will be using just a variable in this particular question. So how we can decide that out of both of these two heap, which heap we are required to choose? So that's where we need to design an algorithm. So 1 2 3 4 5, an odd count, anyhow we don't need to do anything in that context, we will be getting the middle element. But that also how we will get to know that apart from just odd count, how we'll get to know that we are required to choose from the first heap or second heap or both of the heap. So for just for the convenience, we'll always choose from the larger heap, means the heap which will be giving us the largest number, even if it is even count or odd count. So now we will be eradicating the fact that for a single element, means basically for the middle element, which one we will be choosing. And for the even count, we will be required to choose from both of the heap, the largest of the first heap and the smallest of the second heap. So that is the thing. So now on the basis of the size of large, we will decide, means whenever the size of the large which is there, that is smaller than the size of the small, then in that context what we'll do, we'll increase the size of the large and decrease the size of the small. And how we are going to do? Basically, the smaller heap would be having the smallest element at the top, and that smallest element we will be pushing to a larger heap. That would be the thing, so that we can get the largest element from the largest heap. And the smallest element which is being stored in that particular heap, that would be because whatever was smallest element there, now that particular element will be the largest element in a large heap. I'll show you while we are going to implement, you'll get to know. Just hold on here, I'll let you know. This is the first track on which we will be deciding that from which to choose. And then as a size, this will help to reach scenario of odd count. This will help us in that scenario. Now as if the size of large is greater than size of the small, then the largest element is the answer. So now what things I have told is that our algorithm which we are going to design is in such a manner that whatever our larger heap will be there, means the heap which is going to return as the largest number, if the size of that particular heap is smaller than the size of the smaller heap, basically the heap with the small which will give us the smallest number from that particular numbers which are being stored from in that heap, then we'll increase the size of our larger heap by pushing whatever is there from the top of the smaller heap. I'll show you example also here. This is the example. So total element and these are the total element, and this is the element at the top. Total elements and element at the top. We have taken this example 1 2 3 4 5. So now this is the heap which will return as the largest number, and this is the heap which will return as the smallest number. So at the start we will be pushing both of the to both of the heaps, 1 and 1, and here negation would be pushed because this will return as the smallest number, right? So here it will act as a min heap rather than a max heap, so that's why we are just putting the minus here. But just for the simplicity we are taking both of the heaps as the max heap by nature, but just by negating it, it will act as a min heap. Means the result which it will provide from that, it will act as a min heap. That's the thing. So now the next thing which we will do, we'll just pop out the element from the largest heap, and then we will be just having element in the smaller heap which is there. Then we'll see that after popping out anyhow this large heap which is there, that will be basically having lesser size, right? So then we'll pop out from the smaller heap and we'll push the negation of that particular element which is at the top. At this point we will be having just one element, that is the 1 itself, so that will be here. So at this point we can see if there was just one element from that stream, right? So 1 would have been the answer itself, and that's why, and even this larger heap which is there, that is greater in size than the smaller heap, right? So we will be just straightforward returning this particular as the answer. This is that scenario when only one element is there. Now comes the part that in the stream we are having other numbers, means when they called find median after this particular point, then it will return 1 as the answer. That is what I want to say. Then we are having more numbers in the stream, 2 is coming into picture. Okay, so in that context, now we are having 2 also in the larger heap, and the largest element is 2. Now we pushed minus 2, anyhow 1 was popped out last time, right? So because of that we don't have any elements in the smaller heap, and because of that fact only, now we will be pushing the upcoming element, that is the 2, as the negative of 2. So minus 2, and at the top minus 2 would be there. Now the next step, we will be anyhow popping out from the large, so we popped out 2 from the larger element. But now the thing is that at this particular point we have both of the heaps of same size, right? So that's why we won't be transferring any element to each other. But if at this particular point that find median is called, so because we have equal numbers in both of them, right? So that's why we'll just do whatever is at the top of the large heap and whatever is there at the top of the smaller heap, we'll just add them up. Means after negating this, we'll just add them up and figure out the mean and return that as answer. That is what we are going to do. And then next comes the part 3 will come into picture. Then we will be pushing 3 to this also, and negation of 3 to this. But anyhow, because this is acting as a max heap, but acting as a main heap for the negative numbers, right? So here minus 2 will be still at the top, right? Because all the negative numbers are being there, and the maximum out of the negative numbers, the maximum, basically the maximum of all the negative numbers is minus 1, right? Then minus 2 is smaller than the minus 1, and so on, right? So that's why at the top we are having minus 2, and then we'll pop out as usual from the large. And anyhow it was there, but at this point we got the large heap, basically large heap size less than the small heap size, right? So that's why we will be pushing the topmost element, which is 2 here, to the large heap. That is what we will be doing after negating that, so that minus 2 becomes 2 again. And now in the large heap the topmost element will become 2, and here we will be having just minus 3. But at this particular point, if find median is being called, then we'll see what is the size of large and mean heap, large and small heap, right? So here if we see, the large heap is basically greater than the small heap. It is not equal, it is not less than, but it is greater than the small heap. So because of that fact, we will just choose the topmost element which is there in the large heap, and that we will return as our median. So that is pretty much simple. It got done, right? Now next 4 comes into picture. Again same process, popping out from the large heap, pushing minus 4 here, and at this point it becomes equal, right? So when it becomes equal, what we will be doing is whatever is at the top or both of the heaps, we'll just take the mean of the same and return that as a median. Then 5 comes into picture. We will pushing 5 to both of them. One will be getting positive 5, other one would be getting negative 5. Then we'll check for the sizes of both of them. That is what we are doing here, right? And we check that large is having a smaller size, and because of this thing, now we need to push whatever is at the top of the small heap after doing negation of the same and making it is a positive element to the larger heap. And now at the end, if find median is being called, so we can clearly see that a large heap is greater in size, so that's why the topmost element of the large heap will return the answer. And that is how we will be going to solve this particular question. Basically this particular, it is not pretty intuitive, that is for sure, until unless you observe the various test cases which could be there and what all you can play around even with heaps. Because of this streams, the first thing which comes to mind when you are also required to sort is the heap. That is the thing. But how you need to utilize those heap, that will come into picture when you practice a lot and when you tweak around, when you observe, when you take a lot of examples, then only you will be able to get around such type of solution. So that's why it's pretty much important that you solve such type of question more often and do practice. That is the most important thing. Else, to figure out all the questions which are there, like these type of questions which are like based on some of the patterns, like that, so that you can know at least this pattern already exists, this I have already solved. That's the thing. So far I have explained these 2 points which I was saying, means when size of heap is greater or when size of heap is less, what all is being reduced out of that. You can pause the video, move backward, read this, or take a screenshot now and write one more example by your own and check that how you can use heaps for the same. And you will be pretty much able to go ahead by 1 or 2 or 3 or 4 tries, and then on you can go ahead with the implementation part. But first, just try to understand this algorithm which you can deduce for the same. So that's the thing. Now after you are done with all that, now comes the part for the coding. So let us code this particular question. Okay, so it's time to code. It's time to code for the C++. So we will be going ahead with the C++ code. So now in this particular only, we will be going ahead and getting our heap, means basically the priority queue, or rather than this, we'll just go ahead with a private variable In this section, whatever we will be defining, declaring, initializing, whatever we will be doing, that will be all come under the private section of the class. So here this particular is a private variable, priority queue. Priority queue taking as long, because anyhow that can go up to 10 to the power 5. Small and large, two heaps we are taking. Large will return the largest and small will return the smallest. Median finder, that is just a constructor, and we are not initializing anything as such, so that's why we won't be using that. Now comes the part. First we will be pushing in our large dot push, right? And then we will be pushing in small. What we will be pushing in small, we will be basically pushing whatever is at the top of that large. Small dot push, negation of large dot top. That's the thing. Now we will pop out from the large. Now here comes the part, we need to check for their sizes. Because of the sizes only we will be able to determine that what should be the final state of both of the heaps. That's the thing. If large dot size is basically less than small dot size, then large dot small dot, so whatever would be there at the top, that we will be pushing by negating the same, and then small dot pop. That is all we are going to do. So this is what we were required to implement for our add, and this is what I was explaining about the sizes. Now comes the part that after this particular is done, if new number is not added but they directly call this find median, then how we need to handle that. So in this we will be just returning on the basis of size. If large dot size is basically greater than small dot size, because at the start what we decided that we will be choosing any one of the heaps which are there, and that heap will act as that heap which we choose for middle of the odd numbers. So that is what is, and accordingly we have decided this particular thing as well, else the thing could have been opposite. That's the thing. Now if that is the case, then what we will be going to do is we will be just checking if that is the case, then large dot top will return directly that. Else what other thing is, we are required to take the mean of both of the top elements of both. That is what we are going to do. Minus small dot top, we take mean by putting at, right? Here we are taking subtraction because the top element of that particular is negative, right? And we need to first negate it, and we are dividing by 2.0 because we are required to return a double value. So that's why, for the part of typecasting, you can see. And now if we run, we'll check if there is any typo something for compilation stuff. Yeah, there is. Yeah, priority. While explaining, I usually do such mistakes. Haven't put it here. Okay, fine. Let it be. And now just submit it. If all the test cases passed, or what all happened. Yeah, it passed all of the test cases. And time complexity here, login. Rather than L login, it became login. For this particular. That's the scene. Okay, fine. This was all for this particular question. If you have any doubt, you could comment that down. If you have anything in your mind that this could have been done something like this, or any brute force solution also that we could have started like this or something like that, you could comment that down. And yeah, keep learning, keep exploring. And if you really like this video, you can share among your friends. And make sure to like, share, and subscribe to my channel. And don't forget to hit that bell button on. So, this was all. Thank you.